Thank you so much. I prepared the slides for 2 hours. However, hopefully I can take it for we split into training and testing, and they are split further for X train, Y train, and X test, Y test. Now, in the training phase, what we do, we take X train and Y train, and this is X train, and this is Y train. So I just use a line function like this with the help of algorithm regression that uses some kind of optimizer to estimate the value of M and B. So I got the value of M 0.023 and B 1.4. So easy. So we build a model or function from the given input set by approximating or finding the value for parameter values with some intuition and help of exploratory data analysis. That's called EDA. Scatterplot is one type of EDA, all right? And finally, we approximate the values. This training phase is also called learning phase. Why? You're estimating the parameter values. So you're finding the value for the parameters. That's why this is called learning phase. All right. You're learning the value for parameters with the help of input and output data set. Next, testing phase. In the testing phase, you perform three tasks. One is you're going to find the accuracy of the model which you build in the training phase and calculate the performance of your model over other models. Maybe your friends would have got some model, so you have to show the performance that beat your friend's model. And finally, you have to show the reliability of your model. What is that? We will see one by one. So first, you have to show your model is accurate. All right, accurate. Whether they are providing right answers for the test set. So what I do, this is my test data set. It contains two parts, X test, Y test. Am I right? As I showed early. Now I hide Y test. So instead, I'm going to find Y predicted value for each X test. All right. In the previous step, I have X test, Y test. Now I hide it. Okay. So, second. So I just use only X test and I'm going to find what could be the predicted value if I use a model. So I pass one by one into this function. This is what I learned in the training phase. And then I found the predicted value. You see, for 235, I got 4.02 and so on. Now, with the original test set, you see, this is the observed data set. For input 235, I myself measured with the mice 4.12, but for the 235, my model predicted 4.02. Similarly, for each input, this is my observed and this is my predicted. So now what I do, I have to compare them, whether the predicted value is very close to the observed value. You see there? So this is the X test and this is Y test, which I observed empirically from each mice. And this is Y pred, which means the predicted value with the help of a model built in the training time. You have to find the difference. All right. So 0.01 is the difference. And the difference is also called error, also called loss. You can use any term. All right. Like this, for each sample, I have to find the difference, also called error. Finally, I sum up all of them. So the cumulative error or cumulative loss is called cost. So when you say cost, it's an overall error. All right. So I calculated what I want is this error must be as low as possible, close to zero. Now it is 0.52. If I reduce to 0.1, which means that the error is very less for with each sample. So this is how you measure the accuracy in a regression task. All right. Now we mostly get an approximate answer. The predicted value is approximate. So why we call it as error? The original measured values 4.12 for each input, but I got the value for the with the predicted model. So it is supposed to be very close to the original one, but it my model, which I built during training process, made some mistake. All right, that mistake is called difference. So this numerical value weighs, which means adds penalty to the model. That's why we calculate cost, and based on the cost we update values. Okay, it's a back propagation method, which I'm not going to explain here, but you can learn it later if you understood it. So if the model is not good, say instead of 0.52, I'm getting 100.3, way higher. So model is not good. Maybe the input feature is not appropriate to the output feature. So I have to change it some way and rebuild a better model. All right. So this is called validating phase. So validating phase in the sense you are assessing the outcome of the model which you built with respect to the original observed values. That's called validation. Now you have to show how better your model over other models. That's called performance. And there are many metrics. And how random your model behaves. That's called reliability. Sometimes the training set might contain different samples. Testing set might contain different samples. You are running again your model or from the scratch. Now this time your training set might contain different samples because everything is chosen random, isn't it? So how, even if you chose random, your model should provide good result. Am I right? So you shuffle so many times. We have different ways, cross validation or running multiple times and find the mean standard deviation and so on. So in that way, you can show the confidence interval of your model or the expected outcome um, in terms of the probability way of proofing discrete random variable or continuous random variable. With that way, you can prove your model is reliable. Next, supervised learning. The term supervised means that the output feature in your data set, so consider label data set, their input feature, output feature drives your function to be complete. Okay, that's called supervised because you have output feature that drives the model building process. So this is also called predictive modeling, as you are going to use the model to predict for the future input. Next, the supervised learning is trained and tested. So you have to conduct both phase, training phase and testing phase. In the training phase, you build a model by approximating value of the parameters in the function. In the testing phase, you evaluate for its correctness, reliability, and performance. There are two categories in supervised learning. One is numerical prediction, as I already explained. You're using average as output feature, sum as an input feature. The predicted outcome will be the numerical value called regression task. Sometimes you will be predicting categorical value. This is called classification. So you are predicting grade A, grade B, and C. Here you will be using log likelihood method to perform training process. Here you will be using root mean square or sum of squared error, SSE. So you will be learning later about this. Okay. So universal definition of supervised learning is, so you just read and understand. All right. Um, whatever I explain uh, will exactly give you more intuition with this definition. This is just a definition given in every blog. With the understanding now, you can say you are building a function, all right? The function is also called hypothesis. The function is also called task. That's why supervised learning is also called task-driven learning. You can also say it is a function-driven learning. You can also say it is hypothesis-driven learning. It's a math equation. That's it. For example, with this definition, I have given an example for you. This is for you. Okay, if you had understood my detailed explanation, you can understand this example. So I need not bore you explaining again and again with same detail. Let us consider a data set, students mark data set that contains different subject scores for each student and sum, average, and grade. With this, we will understand how regression. So in regression, as I told you, average is taken as output feature, sum as taken as input feature. With this, I perform training, and with testing, what I do, I use different data set that contains sum, and I pass the sum, I get the average. All right, this is called regression. We are going to predict a numerical value. There are plenty of applications: house price prediction, stock market prediction, weather forecast, and so on. So forecasting is predicting the time series numerical value. Okay, so you can't mix up forecast and prediction. Forecast is different, prediction is different. Then there are plenty of algorithms: linear regression, multiple regression, polynomial regression, and artificial neural network. Neural network also can be used for performing regression tasks. Next, classification. Right label is given for each record. You see, I decided grade as output feature, average is input feature. Average is a input feature. So for each record, I get the right class label. Now, with the testing set, with the testing set, I just assume that the grade is not given. I pass the value. I get the predicted grade by the model, and I evaluate it. All right. So this is called classification. There are plenty of applications: fraud detection, email classification, image classification, and so on. There are plenty of algorithms: decision trees, support vector machine, logistic regression, neighbors, k nearest neighbor. Again, artificial neural network can also be used. And there are limitless number of algorithms. You can't learn everything, but the base is same. So this is the whole flow diagram for supervised machine learning, only for supervised machine learning. The input dataset is given. We chose a feature vector. We chose the target or class label output feature. Sometimes we can minimize the number of input features by applying exploratory data analysis and so on. After pre-processing, we get the pre-processed input feature, pre-processed output feature, and we split. This is training data and this is testing data. With the training data, with some machine learning algorithm, we build a model. After building a model with testing data, we evaluate it. So based on the evaluation, we decide whether to choose different machine learning algorithm or choose different pre-processing technique. All right. Once the model gives better accuracy, I deploy it for prediction. So what I do, I deployed in my smartwatch. So smartwatch observes some real-time input. I do the same pre-processing to create whatever pre-processing I did. I do the same because I have applied it to build a model, isn't it? So I apply pre-processing, I reduced features, and I pass into my the model which I built, and that will give you some numerical value or class label. And based on that, you can make a decision. With smartwatch, it makes decision your heart rate and sometimes your stress level. If stress level is so high, it will tell you that in another 30 minutes you will go more stressed state. So you can make a deep breath and so on. So you can perform some action. So that's what I have explained here, step by step. You can just have a glance. This is for you. And unsupervised learning, if there is no output feature to help model building process. Here also we are going to build some function, but there is no output feature to drive model building. So this is called unsupervised learning. For example, here, what would you do with just name, subject, subject 2, subject 3, and just serial number. You can't do anything, but you can extract some patterns. All right, you can extract some patterns. The patterns could be a cluster or association rules. This is called unsupervised learning. With the dataset given, which is unlabeled, you can find patterns like cluster and association rules. For example, you see with subject 1 and subject 2, you can cluster a set of students who are performing well, performing average, performing low. So this is a pattern, isn't it? So there is no testing phase in unsupervised learning. You can't test to show how accurate it is. Am I right? So what you can do is you can manually supervise it. And what I do here, I decide myself with this display, there should be 3 clusters. So this is how I train my model. With number of clusters, I train my model. Okay. Suppose if I say 4 cluster, then my model takes this is one cluster and this is one cluster. But visually I think, no, there shouldn't be 4 cluster. 3 clusters should be meaningful. So this is how I myself assess the model and build the model. All right. So there is no testing phase in unsupervised learning. As a programmer, you got to do on your own. So for example, the number of clusters in clustering and number of variables in association rule mining, as a programmer, you have to decide on your own and you have to test it. It is also called descriptive modeling or data mining or generative modeling. As I told you already, it can be called in any name. So there are 3 major unsupervised learning: clustering, association, rule mining, dimensionality reduction. We will get a glimpse on it. Clustering is grouping similar data points or sample based on one or more characteristics. So with the data set given like this, what you do, you will find students' performance um, who are having similar scores in the examination. So with this, you can assign some grades. Okay, this is B grade. This group of students is B grade. This group of students A grade and C grade. The application is so good, isn't it? With clustering, and there are many applications. So students who fall in this cluster should have high similarity. Students who fall in this cluster and in this cluster should have high dissimilarity. All right, this is the restriction in clustering. The application is customer segmentation. Whether a customer leaves a business, I have an Amazon Prime account. Will I quit Amazon Prime? So they have to apply clustering and market campaign. Can I display some ads in your phone? Recommender system. Can I suggest some movies in YouTube? Can I suggest a friend in Facebook, Instagram? Sentiment analysis. Maybe a group of users in Facebook. Do they convey some malicious activity? And so on. So there are plenty of applications. There are plenty of algorithms, k-means, db-scan, agglomerative, hierarchical, fuzzy segments, and so on. K-means are quite widely used, and there are many algorithms that are meant to be solving some specific problems that are not solved in other algorithms. So you can't learn everything. For a given application, you can just explore in random. Association rule mining. It is like if else kind of rules. If the value of feature is like this, what should be the value of another feature? Or how a set of features together determine something. See, this is feature 1, feature 2, feature 3, feature 4. You see, all these features together determine something. This is called rule 1. And some feature may participate in more than one rule and so on. For example, in the given transactional data, you may observe that most of the time, people who buy milk also buy beer. That's how this transactional data shows up. Am I right? So in all the 4 times milk bought in the transactional list, most of the time beers also take place. So can I decide 70% of the time those whoever buys milk also tends to buy beer? No? Yes? That's how the decision is made in market basket analysis. So with the frequently purchased items together indicate a pattern. All right. So it's kind of a association rule mining. So if somebody buys milk, then they buy beer. It's a if else rule, isn't it? So that's how the association between more than one items in the transactional data is built. There are many algorithms, a priori, eclat, FP growth, and so on. So what are the patterns in association rule mining? First pattern is frequent item set, in the sense if it refers to a set of items that are frequently purchased. For example, milk and bread combination occurs most of the time in transactional data. So they are frequently purchased. Even though milk and bread, they are placed in different location in the bill, it doesn't matter. They are always purchased. Similarly, frequent subsequence. Subsequence in the sense, if somebody buys camera, then they will buy lens. Am I right? But reverse is not true. If somebody buys lens, it doesn't mean that they are going to buy camera, isn't it? So subsequence is very important. So sequence of items that are frequently purchased in sequence. All right. Frequent substructure, which means that finding some subportion of a graph, tree, lattices. So it's quite complicated. It comes in graph theory. So finding some substructure in the given graph, a set of items connected together occur most of the time. So very complex problems we can solve this. That's called data mining. So it is everywhere. It's not just function modeling, also in graph modeling also. Next, dimensionality reduction. It is used to minimize the number of features in the data set. You see there, this is my data set, but I don't need all the features. I need only input feature, average, output feature, great. So all other features are either redundant or not useful for building a model. So I have to remove them. Okay. So having too many attributes. See, this graph shows that the x-axis is the number of features. If I have very less number of features, the accuracy is very less. If I have more number of features, the accuracy is less. If I have optimal number of features, the accuracy is high. So dimensionality reduction itself is a huge research problem that determines accuracy of the algorithm. It not just the data set, but which part of data or which feature you are considering for building a model. There are two ways in minimizing number of features. One is feature selection, which means that selecting the most relevant subset of features. If I have 10 features, I should take 2 or 3 from 10 features. All right. I use statistical scores like information gain, Gini index, gain ratio, covariance, correlation. There are plenty of techniques to choose subset of features from the given feature set. But the restriction is the resulting set of features must be subset of the original features. All right, that's called feature selection. Next one is feature extraction. Creating new features from the existing feature is called feature extraction or feature engineering. Feature engineering. So what I do, if I have n existing features in the data set, I create 1 or 2 feature that can represent all the n features. So now I did not use all the n features. Instead, I can use only those 2 features which I created fresh, new. All right, that's called feature extraction or feature construction or feature engineering. All right. So the applications are big data visualization, structure discovery, and there are plenty of algorithms. PCA, SVD, TSNE, LDA. You see there, if there are 100 features, I find the principal component, maybe only 2 feature. Principal component 1, which means feature 1, principal component 2, feature 2. So I extracted 2 new features from 100 features, which are then used to display. All right, so I cannot visualize 100 features. There is no visualizing tool, but I can shrink into two feature that helps us to visualize like this. So I can cluster now. Am I right? I can do clustering now. So like this, the feature reduction helps us. Next, reinforcement learning. So this is going to be a bit tricky to understand, but it will be so interesting to understand. So what is reinforcement learning? Reinforcement learning is mainly used to mimic living objects behavior. Why does it go like this? One second, let me erase. Unlike supervised, unsupervised, reinforcement learning is used to mimic living objects behavior. It may be a human, it may be a rat, it may be cat, and so on. That is represented by a graph, which what I say here, there is a graph. In graph, as you know, there is a set of vertices, set of edges. Vertices denote an action, edge denotes a relationship. So for each living object, the graph is different. Am I right? So vertices is a state, edge is a relationship. If there is an action, what I mean is moving across many vertices or states. So this is how, that is the reason I explained the graph data in the very beginning, different types of data. Am I right? So what we can do is a living object's behavior follows certain pattern. For example, in everyday activity for a human, wake up in the morning, drink some water, take bath, go to job, take your meal, come back from office, get some entertainment, and so on. Despite this is random in different time period, you will tend to follow the same routine next day. Am I right? So even though your activities or actions are random every day, it has some pattern. That's how the detectives record about your pattern. Am I right? So sequence of actions. So what you're going to do, you're going to predict sequence of actions, which is also called path in a graph by using reinforcement learning. That's it. So for solving a problem, first thing is you have to pick up vertices or state. You have to decide the relationship among each state, and you need to know what different types of action. Some action may traverse through three nodes in different directions. Some action might traverse through different vertices and different length of vertices and so on. All right, so it's like predicting a pattern, um, an activity that happens traversing through a set of vertices. All right, that's it. So if you understand this, then understanding reinforcement learning is going to be very, very simple. So ultimately, you predict a path that involves more than one vertices from the given vertex. All right. So ultimately, reinforcement learning deals with finding the optimal path for a given action, which means from the given state, from the given vertex, what is the optimal path to the target vertex? That's it. Maybe shortest path, one option, but that is not true. But just I'm saying that maximizes the reward. There can be many number of path, but the path that gives maximum reward is called optimal path. And each time step, in the sense, visiting every vertex is one time step. Okay, so time in the sense not 1 second, 2 second. It's visiting one after another on each vertex. All right, in real time. So you're going to find the optimal path from the given vertex that maximizes the reward. Consider a player in chess game. You see, chess game. Have you played with online competitor, which means computer? So what is given here? You see an environment in the chess game. So environment is decided or designed as a graph. So graph involves vertices, edges, and actions. So all possible moves in a chess game is called environment. So first you have to record all possible moves by each coin in the chess game. So like that, you have to build a graph, how big this would be. So collecting this data set itself is huge. There are some data set available online that contains graph for the chess game. It contains states, also called vertices, and edges, also called relationship, and actions, also called given vertex, what should be the path to the target vertex, optimal path. Then agent. In reinforcement learning, always you heard the term agent. In the chess game, there are totally 16 coins at each side. So 16 plus 16, 32 coins are available in the chess game. So each coin is an agent. For each coin, a separate reinforcement learning task is running. All right. So each agent builds a model. That's it. So for the next move for a player P is decided based on the agent that gets the maximum reward. Say now I'm playing the white uh, side. Now which coin I should move? Should I move horse, queen? Which one? So uh, each one is an agent. Each one builds a model. The model that gives maximum reward, I will choose. So maybe moving the horse gives maximum reward such that I can defeat the opposite team. So I will move like that. So this way you see for each coin, the reinforcement learning algorithm tries different moves and builds some decision that maximizes the reward. So if I move this one, it gives me more reward, which means that I can more possibly win the game and so on. That's it. So reward in the sense it's a numerical value that emphasizes you. The more better you can win the game and so on. Therefore, each agent is forced to reiterate the possibilities to maximize the reward. So that is called reinforcement learning. This word reiterate. Every agent is forced to re-evaluate possibilities to maximize the reward. That's called reinforcement learning. All right, have you watched PUBG game? So each player is a agent. All possible moves by an agent is determined by the graph called environment. So environment will be having a huge graph. Each player navigates through the graph. All right, they have restrictions on the graph. So that's how it is. It is enough to have some visualization and understanding. You need not go much deeper. Maze game. Here rat is the only agent and it bumps through all the ways because it did not find, finally it comes out of it. Sometimes it tries the same way which it already explored because it did not know, because there are many ways, mostly there are blocks, but finally it comes out of it. So the environment may be a real world or simulated world. Simulated world in the sense like games. Real world in the sense the robot talks with us, walks with us. So how it sees, how it behaves like a human. So it has to mimic. Human also is the same. We see different direction and look at the road to before crossing whether some vehicle comes like that. So everything is random, everything is a state. Our decisions are not infinite. We are confined with a less number of decisions for each state. So each PUBG player and rat in the maze are agents. Each agent is an RL algorithm running separately. Applications of RL. Hopefully you know metaverse that will take you to the next level of madness because you need not come out of the home. Wear some uh, wear some glasses your eyes that will take you to the illusionary world where you can buy land, buy car, choose your friend, choose whatever you like. All right. So metaverse is a huge application of reinforcement learning, self-driving cars, games like PUBG, robotics, drug discovery. There are plenty. Unlike supervised, self-supervised, we have no error metric, which means what is the error of each try? There is no error metric. Instead, we use reward based decision making. That's why it is called reward driven. So based on the reward, it's a numerical value. If it is 100, it's very nice. If reward is less than 10, the decision will be very bad. So mapping state to action is called policy. So it's a function again, a mathematical function. Each agent in chess has its own policy. All right, because queen can move any direction, um, but any number of steps. But king can move only one step, even though it can move any direction. So every agent in a game is defined by a function, which means the number of moves, the direction of move, and so on. In the training phase, what we do, we um, we we make a abstract diagram like this. This is called environment. Then environment is converted into matrix state action. So this is state, this is action. Now I'm in state 3. What is the next action? Maybe I can take this one, and this one. That's called action, moving from one state to another state. And the output will be output matrix called Q matrix. So we pass the state action with reward matrix and we get Q matrix as an output. The path that maximizes the reward for each agent using Q learning algorithm is applied in training phase. Finally, we get Q matrix as an output. If an action is correct, we get positive reward. If action is not correct, we get negative reward. The objective is to maximize the reward and minimize the penalty for long term, because a game never ends until either you are defeated or you defeat the opponent. Am I right? So until the game goes on, you have to maximize the reward. In the testing phase, unlike supervised unsupervised learning, the outcome of the training is a converged Q matrix. It's um, unlike supervised unsupervised, reinforcement learning involves a lot of probability related stuff. Okay, so the output is a Q matrix that contains transition probability. Maybe if you learned already Markov decision process or Markov chain, you can easily understand reinforcement learning. So I suggest, if you want to learn reinforcement learning, first you need to know some basics of probability, like discrete uh, discrete random variable, continuous random variable, and some distribution function, and Markov chain, and then learn reinforcement learning. The matrix contains some numerical values that emphasize the best possible moves for each from each vertex. Sometimes we don't get the Q matrix. Instead, we optimize a policy function. So as I told you, each coin in a chess game contains a policy function that determines how many steps to move, which direction to move. All right, we have to optimize that function. In that case, we don't get the matrix output. So there are two choices. Either you can decide to get the matrix as output or the optimized function as output from reinforcement learning. So we assess them. We assess the matrix if we get, or function that is optimized if we did. So we assess them. But most of the time, unlike uh, unlike unlike supervised unsupervised, assessing doesn't give the real value, because your program is going to meet the real person in the future. So I train my chess game Later, the chess game is put on internet, which will deal with the real human. Am I right? The real human can play like anything. That the data that doesn't contain such actions. Am I right? In that case, your the chess program will be defeated very easily. So we cannot really evaluate how well our model performs, but with the data which we have, we can just assess. Or in the real time, with the man trying to compete with your program, we can just collect some value and then train. All right. Some argue that reinforcement learning is semi-supervised learning, as there is a little supervision because reward. If reward is high, the path is good. If the reward is not good, then the path is not good. We should not take that path in the graph. Am I right? So it gives some guidance. So some argue that it is semi-supervised. Some argue that it is not semi-supervised. So it is up to the one who discusses and defends. There are two categories: model-based, which is model in the sense, what is model is a function. So for each agent in the game, we have a function, also called model, also called policy. Am I right? The function can be deterministic. You can decide this is my function y equal to mx plus b, ms plus c. Stochastic, I don't know what value we will get for this. Stochastic in the sense random. That's called stochastic. So there are two types in model based itself. May be tested. We can, after building policy for each agent in the game, we may test, but I don't know the test will give you good score or not. If the test may be failed, but if you put on real time, it may be winning all the players. Who knows? Next one is model free. Model free in the sense like we are building a Q matrix. So each agent doesn't contain any function, but it builds a Q matrix that contains best possible moves. Okay, here testing is not reliable because each possible move is already recorded. In the real time, there is no further learning happens. So some algorithms like Q learning and SARSA. 1 second. Here the four questions which we already discussed. Is this email spam or not spam? This is, you have to answer for each question with the understanding we got all through the slides. So let's highlight input in blue, knowledge in green, and the problem in red color. For example, is this email spam or not spam? For the incoming email, here mail is input, and making a decision spam or not spam, it's a function. And the problem is classification. Similarly, predicting house price. Okay, house price is a regression problem because we are going to find a numerical value. And identifying students under over performance, we have to do clustering. Okay. And finally, how will you help a rat to come out of a maze? So it's a real reinforcement learning problem. All right. So like this, you can put a table and you can answer the following questions. Okay, so that's how you can do it. In the next session, maybe on 28th, I will cover key differences among the learning problems. Maybe you can just have a glance. So I will distinguish different learning problems. So based on this only, you have to decide for your data set which learning algorithm you have to pick up. And other type of classification, and I will show you up why neural network, why not classical machine learning algorithm. And I will tell you how handwritten digit recognition works. I will tell you how text audio classification works. I will tell you how regression using neural network works. And I will tell you how deep learning emerged and what is deep learning, what is neural network, what is machine learning, and different types of deep learning, and finally advanced concepts in machine learning. So how you have to learn all these techniques one by one, and finally what is model deployment, and we'll end the game. So maybe another 30 minutes on the next session. After that, I'll be handling the text analytics in very, very simple way that you can visualize. Okay. If you have any questions,